present on forecasting migration from Ukraine using organic data, strengths and limitations. So yeah, thanks, Lisa, for joining this event, and over to you. I think you're on mute, sorry.
Okay, can you hear me now?
Yes, we can hear you. But now your slides have disappeared. They were visible just before.
That's okay. I think when I showed my slides, I couldn't unmute myself. So let me now share my slides.
Okay.
Are my slides visible now?
Perfect.
Okay, well, thank you so much for giving me the opportunity to speak today. I have really enjoyed this session and learned quite a bit, and I hope that you can kind of see what we're thinking about in the context of our migration project as well. I'm going to basically use Ukraine as a case study to explain the strengths and weaknesses of organic data. And we've had a lot of good examples today. So I'm even though we don't use all the examples that have been discussed today, I'm going to talk about why we sometimes use some of them and don't, and maybe give you some insight since we've been working with organic data for quite some time. So simple thing that we want to do, right? All of us want to try to predict when, where, and how many people will move from one location to another. Currently, there's no good early warning for this, and when UNHCR and IOM and other agencies need estimates, it can be difficult for them to get. There's been a lot of discussion about internal displacement versus across borders. And so are those processes similar? Are they different? How do you model them? Should you always model them independently or not independently? Most people focus on one of those. And I think that's also something we've really been grappling with, is how to design models that over time may consider both. But as of right now, we're doing the same. We're kind of thinking about one at a time. So specifically, we focus on how we can responsibly blend publicly available organic data with traditional administrative and survey data to improve early warning of forced migration. And I use the word responsibly. It's been brought up a few times that people don't always think about privacy and other issues when it comes to using organic data. And so that's really important for us to do. And we believe this form of data blending is crucial for tackling kind of these large scale societal problems because of all the data gaps and all the missing data that exist for countries of interest. However, when sudden conflicts emerge, like what happened in Ukraine, traditional data may not be available or may not be useful for the types of analyses that need to be done. We know that almost 12 million people left their home because of the Russian conflict. About 5 million went overseas, and about 7 million were internally displaced. And there are about 13 million who didn't leave, but wanted to, but couldn't because of security risks and unpassable routes and so on. So now when this conflict arose, we decided to take our question and reformulate it a little bit and ask the question, how can we responsibly use publicly available organic data to provide information about impending movement? So we don't have the luxury now of having these other forms of data, and what organic data is available right when a crisis starts, and how can we go about building variables that will measure where people want to move and when they might be moving. Surveys in this instance can be very difficult to deploy rapidly, and the administrative data may not contain that timely information that we need. I think we saw a really nice example of Google Trends earlier, and I will talk a little bit about Google Trends later. But if organic data can be viewed as a new source during these times, They're important because they offer real-time rapid data for analysis and dissemination. There's lots of forms of them. So one of the things that I will harp on a few times or say a few times is that no one organic data source is good enough to look at different types of conflict. So as many of these different types of sources you can gather that in a responsible way, the better off you will be for modeling prediction. Social media, satellite data, newspaper data, Google Trends types of data, there's lots of good options. And deciding on which ones to use for different conflicts or trying to use them all would probably be a more ideal scenario, but it can be costly. The infrastructure for that can be costly. So what does organic data allow us to measure? We've talked a lot about this today, so I'll do this very rapidly. But we want to be able to understand behavior, events, public opinion, and perception. And so behavior starts to help us understand flow counts, movement tracking. We can see what types of topics people are discussing, and those topics may be direct or indirect indicators of displacement. Clearly, different types of events have an impact on forced displacement, so we want to keep track of those. There's public opinion, and that can be really important when policies are changing, particularly ones related to borders. And then perception. Is it the case that people have a perception of immigration being a problem at certain borders versus other borders? Now, many of these different types of measurements that we create can be done manually through dictionaries and development of dictionaries. There's also some strong techniques that the computer science and statistics communities have developed where they think about things like topic modeling, event detection, sentiment detection, stance detection, and emotion modeling using where these dictionaries are automated or at least partially automated. And there's a really nice rich literature around that, but it's still on short texts like posts, it's still problematic in terms of how accurate they are. Okay, so I'm going to start with this theoretical model of forced migration. And as we've heard numerous times today, there are lots of drivers of movement, and many times they're intertwined in ways we may not understand. So the most common macro drivers are environmental, political, economic, disease, social, and demographic. There are micro drivers such as demographics, financial resources, and attitudes. And these feed into a perceived threat that an individual or family may have when they're deciding on whether to move. That perceived threat also has inputs from intervening variables, both meso and micro, things like the weather, the terrain, infrastructure, laws and policies, and prior knowledges or preferences on the micro side. Those can lead to understanding of to the perceived threat of food insecurity, physical insecurity, health insecurity, and finally, those are inputs into forced migration. And if that wasn't complicated enough, and we know this is a very complicated topic, we also have temporal variation in terms of the types of data we can get, and we have spatial variation. It's very rare that we have all the data we want in the exact resolution spatially and temporally that we want as well. So the reason we like to look at this type of a theoretical model for forced migration is because it allows us to kind of think about migration in a more generalizable way. And to use construct variables that map to these different theoretical components of migration, to these different drivers. Okay, so I'm going to do two examples, and the first example isn't the full forced migration measurement. It's just to tell you how I think about constructing variables. And then the second example will be a flow example. So the first example thinks about internal displacement and insecurity. So one of the things we ask ourselves is, how do we measure each of these different drivers and this perceived threat? how do we measure insecurity using different types of social media. I'm going to focus on Twitter because Twitter is a public forum. Most people who post on Twitter know that it's their tweets can be viewed by anyone. And so we're going to focus on that. By no means do I think Twitter is the best social media platform, but I do think there's a lot that can be captured there. So my examples will focus on Twitter when I'm talking about social media. So how do we measure insecurity using Twitter conversation? And if we're looking at insecurity conversation, how does it vary by time and place, and for that matter, by language? So we consider using IOM data to examine spatial dynamics of internally displaced persons and look at the volume of conversation about these different types of insecurity before and after the invasion. And remember, we're focusing in on 3 types of insecurity: food, physical, and health insecurity. So what we do is we literally build dictionaries, and for each of our different drivers, we look at words and phrases that might indicate that people are talking about a particular type of insecurity. And so here are some examples of some words that we used for physical insecurity, food insecurity, and health insecurity. And we basically construct what we call buzz variables, conversation buzz variables, where we're trying to see what people are talking about each day in the language of interest. And here we focus on Ukrainian. We also have contextual measures, those other macro drivers we were talking about, and there are some examples of those here as well. So using these, we first started looking at Ukraine and looking at the IOM data. So this is from IOM. And if you look, you can see where people are leaving from. You can see most are leaving from the east and the north. And that's great. We wanted to actually see if we look at location mentions that people give, and we look at what they mention in their tweets in terms of locations, can we use that to see where people may be moving to, or can we see how certain insecurities are connected to these different locations? So just a short little example here. We're using the Twitter Decahose. That's a 10% random sample of all daily tweets across all languages. Again, we're focusing on Ukrainian, and we're looking just at the first month of the conflict. And what we find is that if we look at that physical insecurity indicator, and we look at the top 25 cities by region, and the percentage of conversation that's associated with this insecurity indicator, that it actually correlates very well with the cities that people were leaving. So in other words, this wasn't going to be a good indicator of movement in the future. This was actually an indicator of where people were trying to leave, because they're talking about physical concerns that they have in the place they're at. And so I think one of the things I really want to show here is that we can use these indicators not always for our final purpose of movement, but sometimes to understand how people are feeling, their emotions, their insecurities, and even what the conversation topics are, how they're changing. If we look, for example, at some of these different topics that we were just talking about, the invasion is this purple line. We see that the physical insecurity conversation is the highest, but there are other conversations that are taking place, and the dynamics of them are changing. They were changing much more significantly than they were prior to the invasion. We can also kind of see this if we look at a differencing analysis. So here we calculate the difference between the daily counts of conversation and the count from the prior day. So it's the first differencing, pre and post invasion. And basically what this tells us is that there is structure in this conversation about physical insecurity, and that structure can inform what we can learn about movement. We do fit an ARIMA model to this, and I'm happy to talk about that later if people are more interested in this, but I'd like to move on to my second example, which was, well, we can see one of the limitations of doing this internally is we have to focus in on a subset of cities that, that people are talking about sufficiently. And what we're seeing is people are talking about the cities that they're currently in, not necessarily the cities that they're moving to. So that particular physical indicator didn't help us with that movement. So the question became, well, what about if we focus in on external international migration? And let's look at the bordering countries a little bit. And having said that, we're not done with internal displacement. We just believe that we need to add more organic sources to capture that better. One of the organic sources that we're adding to our internal models is Google Trends. And so we're very interested in seeing if we have that type of success that Andrea talked about earlier. Okay, so here are the cumulative flow numbers of the neighboring countries. We see that Poland has received the largest share of migrants, and this is followed by Romania and Hungary. And if we look at the UNHCR flow data, I think it's really, there's a couple of interesting things to note here, and the y-axes are all different. So, you know, Poland is getting much more, but the trajectories are very similar. You have this kind of big hump that occurs, and then you have this panhandle that comes afterwards. And so this is not surprising, right? The conflict emerges, there's going to be more movement, and then that movement is going to slow down. But if we're building a model of this, then we have to think about how to model this change that's occurring, right? So in our case, it's really important for us to conduct a change point analysis to estimate the width of that hump and to understand how to build a model that can make the adjustment from this stage 1 of the crisis to the stage 2 of the crisis. So this was something that we thought a lot about as we were building out our model. So I mentioned Twitter data. For this particular example, I'm going to use Twitter and ACLED data. The Twitter data gives us kind of those insecurity types of variables I discussed before, and the ACLED data gives us some event data. We actually originally were using different types of geotagged data from different on-the-ground sources. And what we found was ACLED seemed to be mimicking that very well. So we stopped collecting that ourselves. And they also include an event death count. And we're going to look at that as well to understand if that can be a good indicator. So the 3 categories of variables, is everything okay? Okay, sorry. The 3 categories of variables we construct from Twitter are flee variables, insecurity variables, and context variables. So those flee variables say, I'm moving, I'm leaving here, I'm going there. They're actual direct indicators of movement. The insecurity variables we talked about before, and the context variables were some of those macro variables we discussed before as well. The ACLED data is event data, and this map just shows you where the different events occurred. And you can see this data over time, both the events and the deaths. And I think it's worth noting from this chart that we can see a lot of the events, the highest days of the events actually occur before the invasion. And it'll be interesting for us to understand how that impacts our predictive model a bit. I do also want to mention, right, just like with Twitter conversation or other types of conversation, anybody can say anything at any point. Well, events work in a similar way as well. When you're organically collecting events, people before a crisis occurs may really be talking more about certain events than after it occurs, because it might just be harder to get that data at that point. Okay, so kind of a standard model that's used a lot for predicting migration is a gravity model. It makes certain assumptions. It assumes spatial and temporal alignment. It assumes that the flow is directly dependent on the drivers of the covariate drivers, and it assumes that the process is homogeneous through time. For us, the issue is with the types of data that we use, that all of these assumptions are broken. And so because of that, we tend to focus in on using a Bayesian model. So we're going to use a hierarchical Bayesian. Hierarchical Bayesian models allow us to kind of vary the importance of the covariates at different stages of the conflict. And I've already kind of mentioned that we have multiple stages here. We have temporal and spatial variation. And so that's something that we want our model to be able to represent. Our Bayesian estimates of mixed hierarchical models makes specifying all our complex dependency structures more explicit. So one of the things that we want to be able to do is to explain which of the components of our model is driving the movement. And this type of explanation can be really important for those who are on the ground. And our predictions produce posterior probability densities rather than point predictions, which we think are important in this context. Okay, so let us go to the model. So we're modeling here the intensity of people that are beginning their journey out of Ukraine. That's S of T, and we're going to treat it as a linear function of the different indicators. So we have our buzz on a particular day. We have our unknown regression coefficient for our buzz type. We have our event counts and coefficient, and we have our event death counts and coefficients. And this C of T here is going to represent the change point, and I'll come back to that in just a second. Okay, so we want to model our arrivals. So we want to model the number of refugees arriving from Ukraine on a given day at a given destination D. So that's going to be our Y of DT. Our green here is the proportion of our explained flow to that destination. This blue is going to be a Gaussian windowing function that we have. And the reason that we have this is because we don't know the exact point at which this change is going to occur. And we don't know how big or small our lag should be. So this is going to help us account for that. The red is what we saw on the previous slide, and our dark blue here is our destination specific intercept. Okay, so I was just talking about the change point, and we want to capture, we want to be able to model what happens before the change and what happens after the change. And this is allowing us to do that. It allows us to have parameter adjustments for that change. Our setup's pretty straightforward. We use JAGs and we use Python JAGs for the Gibbs sampling, 20 chains, 50,000 iterations, and so on. Let me share some of our results here, and I don't have time to share all of them, but I'd like to share a few. Okay, so we have stage 1 and stage 2. And we learned a whole bunch of different parameters here. I want to point out a few things. In stage 1, we see that our buzz variables related to health and security, political and religion are actually have the largest effect. And in stage 2, it's actually our event and death variables. So here we see right away that had we only had one of these organic variables as opposed to both, that our models would not have been as strong. And I I point that out because I really think it's important that we add in as many different types of variables as we can when we use organic data, because we just don't understand which ones the local population will use the most. In terms of in-sample estimates, in terms of our mean estimates and our predictions here, we have the blue is the UNHCR flow data, the gray is our fit, and the line is where our change point is that was predicted. And I'm going to say it was at day 20, but I'm forgetting right now what day it actually was that change point occurred. And so what we see here is that we do pretty well at noting that there is a change point and modeling that pretty well in a good way. This gray part is the predictive out of sample part.
These are just quickly that we already over time. So yeah. Okay,
great. Thank you for telling me that, because my watch said something else. So let me just go to the end. So I'll say one other thing. We did an ablation study to see if buzz or events, how well they each did and how well they did predicting forward. If you had 20 days versus 30 days versus 40 days. And it works. It's really important, again, to understand that both groups give us different types of results in the different stages. I just want to finally say that I don't think we can ignore organic data at this stage when we think about forced migration, but we do need to think about how to construct meaningful variables. We need to think about how to use these meaningful variables when sudden conflicts occur. And we need to understand how to use more advanced statistical modeling approaches to capture the variation between the missing data, the temporal and spatial inconsistencies. We also have been working to understand the role misinformation plays on forced migration and how that influences where people decide to move.